Hello, ladies and gentlemen, and welcome to the world's first and last What's That Sound? I'm your handsome host, Dennis Kalinin, and below me are here three fine gentlemen. First up is Joel Lawrence. How are you doing, Joel?
Well, thank you for asking, Dennis. I'm doing pretty good.
Thank you so
What
much, Joel. Everyone, give Joel a round of applause. All right, next up is Bowen. Bowen, how's life?
Um, I feel lost right now. I don't know where I belong on this planet.
And last but not least, we have John Fitzgerald. Now, John, what's the catch? Why are you here? Aren't you like a billionaire?
Well, actually, I'm here because although the physics may be theoretical, I believe that the fun is definitely real.
Now, those are some wise words coming from John. All right.
Good answer.
Well, now that we're all here, let's get started. Now, the rules of the game are quite simple. It's Jeopardy style, but not like Jeopardy at all. The three contestants take turns choosing one of the tiles available on the board. If they get the answer right, they win that much money. If they get it wrong, they lose that same amount of money. In the end, we count up the scores, and one person comes out a winner. Joel, you're up first. What's your choice?
I'll take pitch and sound intensity for $200.
Pitch and sound intensity for $200. What is the scientific pitch standard?
Is it C256?
C256? It is! Correct! Good job. Bowen, you're up next.
I'd like to try speed of sound $400, please.
Speed of sound for $400. The more blank the medium, the faster the sound travels.
Yep, got it. The answer is more dense.
More dense. That is correct. John,
What I tell you?
So I'll take longitudinal and transverse waves for 400, please.
Longitudinal and transverse waves for 400. The two sections of a longitudinal wave are compression and blank.
I believe the answer is rarefaction.
Rarefaction, that's correct. Joel, you're up again.
I'll take pitch and sound intensity for 400.
Pitch and sound intensity for 400. What is the threshold of instant perforation of the eardrum in decibels?
160 decibels.
Wow, that is correct. Bowen, you're up next.
Let's say.
I'll try my luck with $200 harmonics.
Harmonics for $200. In a standing wave, what is the relationship between nodes and antinodes?
Okay, I think final answer, antinodes plus 1 equals nodes.
There's always one more node than antinode. You're right.
Well, that counts.
John, you're up next.
Longitudinal for 6, please.
Longitudinal for 6. An object free to vibrate tends to do so at a specific rate called the object's natural or blank frequency.
Is the object's frequency?
Frequent frequency? Nope, it is the resonant frequency. I am so sorry, John.
What?
Joel, you're up next.
I think I'm gonna take harmonics for 800.
Harmonics for 800. The fourth overtone in a series is equal to what harmonic?
The fifth harmonic.
The fifth harmonic, that is correct. Bowen?
Okay.
I'm gonna go with pitch and sound intensity $600. My good sir.
Which one has the higher sound intensity? A busy street or a vacuum cleaner?
Okay. Vacuum cleaner.
That is correct. A vacuum cleaner is pretty loud. John, you're up next.
Speed of sound for 600, please.
Speed of sound for 600. Is there sound in a vacuum?
Well, Owen said that a vacuum cleaner. I know that vacuums are loud, so I'm gonna say yes.
Nope. I'm sorry, John, but that is the wrong vacuum. Joel, you're up next.
I think I'm gonna take longitudinal and transverse waves for $800.
For 800 again. Explain the principle of superposition using the term interference.
Something with constructive and destructive interference, I'm pretty sure.
Let's see. It deals with constructive and deconstructive or destructive interference. Very well done. Bowen, you're up next.
All right, I'm gonna go for a big boy question and take $800 pitch and sound intensity.
Pitch and sound intensity for $800. The phenomenon observed in space, known as redshift and blue shift, is due to what principle describing a property of waves?
Easy question. I believe it's called the Doppler effect. The
Say that again?
Doppler effect.
The answer is the Doppler effect.
Yep.
Good job,
Yeah.
Bowen. John, you're up next.
Harmonics for 400, please.
Harmonics for 400. What's the difference between an open tube wave and a closed tube wave?
A closed tube wave has an antinote.
Let's see if that's correct. Closed tube wave does indeed have an antidote at one end. Joel.
I'm not sure. I think I might take speed of sound for 800 at this point.
Another 800. Wow, Joel. What is the speed of sound in air at 0 degrees Celsius?
I'm gonna have to say 331 meters per second.
331 meters per second.
That's
That is
such an
correct.
easy question.
Bowen.
I'll take, I think, speed of sound, $200.
Speed of sound, $200. The speed of sound in air is dependent on what variable?
Temperature. Duh.
Temperature. Good. And John, final answer, final question. What is it?
Harmonic 600 is left, I believe.
Yep. And which has the longer wavelength, the third harmonic or the seventh harmonic?
Longer. That would be the third harmonic.
The third harmonic, that is correct. Ladies and gentlemen, that is it for the casual questions. Now, moving on to the finale. All right, ladies and gentlemen, and now we have the final question. I'll tell you how it works. I'll announce the last remaining question on the board. The first person to raise their hand and say, I'll answer it, will get 15 seconds to answer that question. If they get it right, their score is doubled. But if they get it wrong, they leave with nothing. $0 to their name. So, without further ado, let's get started. The final question is longitudinal and transverse waves for $200. The question reads, what is the most prominent example of a longitudinal mechanical wave?
I'll answer it.
All right, Joel? You'll have 15 seconds to answer this question. Think wisely, think carefully. Your time starts now. Time's up. Joel, what is your answer?
Before I answer this, good game to everyone. Bowen took the L, and I wanted to say water waves. Dennis.
What?
Sorry, my bad. I'm joking. Tsunami waves. Final answer.
All right, Joel, we got your answer. Fortunately, the right answer is sound. Sound waves. All right,
Yikes.
and now I have to count up the scores and see who the winner is. So I'll be right back. Oh, actually, does anyone have a pencil?
Yeah, I'll pass one up.
There you go.
Oh, thanks. All right, I'll be back with the scores shortly. I am back with the test scores, and boy, let me tell you, there's something unexpected. The winner of this year's What's That Sound is Bowen!
Let's go! Let's go! Hey, just like I thought.
Congratulations. Everybody, thank you
Give
so
my
much
money.
for playing. And everyone watching at home, I hope you enjoyed.